I hit on the idea of making this talk after seeing some videos with Joe talking to Tony Hare about the academic side of concurrency and cooperating agents, which is all correct. But I thought I would present a little bit from the back side of that coin. So, well, back in you were talking, Richard was talking about the 80s. Well, I'm talking about the 70s. I mean, when people were starting to use computers, processors to control equipment, and that would be a matter of a few thousand words. And there wouldn't be things like operating systems or schedulers. It would be something called job table monitor, which simply would sort of call one program after each other. And the first thing the program would do is to check some sort of state variable to see what was I really doing. And no program was allowed to take too much time because it would steal time from the others. So this was a very simple structure. Then, I don't know if you have heard about the Ericsson's AXE10 system, which is one of the great big industrial successes. It's been sold to sort of 110 countries or something. And for that, they created this language and software architecture based on what they call blocks and signals. And this was actually perhaps the first system programmed in some sort of high-level language. At that time, operating systems, real-time systems, compilers, and so on were all written in assembly language. I mean, but this Plex language, well, it looked vaguely like BASIC or Fortran. But the clever thing was that these so-called blocks could not interfere with each other's memories. And it was built on that they sent messages or signals to each other. And so there were several sort of entry points. And the first thing at every entry point would check some sort of state variable. What am I doing just now? And this functioned like a module and a static process. So, for instance, a transaction or a telephone call wouldn't be represented by a block like this. It would be sort of represented by lots of information in all of these. So it was rather tricky to sort of understand really what had happened, because all of these blocks were sort of very fragmented little code snippets from each enter state. Anyhow, I mean, this system worked very cleverly. And one of the things was that they had two processors, one active and one standby. And they had the idea that they could load new versions into the standby processor and switch over. That idea was then later taken up in Erlang. And this is a person that has actually been very important. I don't know if he invented all of these things, but he has promoted them. And of course, modules that are sort of static, that's what you write, that's what the designers create. The processes are the dynamic, and then processes communicate. And they also invented something very clever called PL-type languages. You know, I mean, he was the creator of Pascal and the syntax diagrams and so on. And when they were writing a Pascal compiler for some IBM machine, he invented this PL360 language, which was a sort of high-level assembler. And this was a language that I was involved in inventing. We had a processor called APN163, so we invented a language called PL163. And this was, the PL language was, I mean, things like if register 5 greater than 100 then, etc. So it was at the level of the machine code and got very efficient, but it sort of looked vaguely like a proper language. But it had processes. and some sort of simple scheduler, so that when a processor got waiting for some sort of message, it stopped there. And the scheduler remembered where it was, so that when the message came, it would continue from there. We thought this was sort of very, very clever. So that was, well, as a simple scheduler. And this is actually when Mike and I started cooperating, because I was involved with projects creating these sort of programming environments and inventing this language and so on. And Mike was a user because he was building a military switch. And I remember we had an argument for about half an hour because he thought this was the most ridiculous thing he had ever seen. But then he started studying the scheduler to understand how it functioned, and which was, of course, written in PL 163 itself. So from that moment on, we've been working together. Then Modula and Modula 2, those were languages created by Wirt, and with modules, processes, and process communication through some interface modules. A little bit tricky. There was an interface module, and only one of these procedures can be executing. And this is a very strange photo which sits on my guest bedroom wall. We went, a few people from Ericsson who have been sort of working on software technology, to visit Niklas Wirt in Swedish. I don't really remember what this was. Pascal for telecommunications, that was some sort of language we were sort of messing around with. The only thing I realized is, of course, that we would have very colorful manuals. But when we were there, that was actually the moment that he presented Modula. So I went on a lecture where he was presenting Modula, talking in High German. And at the end of the lecture, the students didn't sort of applause, but they were sort of knocking on their desks. That's apparently some Swiss-German tradition. But then it was becoming sort of important. The big guys moved into this. I mean, this CCITT, that's a great big United Nations organization. It's located in Geneva. They are creating all these sort of standards for mobile telephony, etc., so that all suppliers and all operators are able to sort of communicate. So they decided, yes, we have to do something about programming languages. So they set up a committee and created this CCITT high-level language. Contained modules, processes, and then there were 3 methods of process communication. And I have a book at home about CHIL and other languages, and this is what it says. I think you should read this. It says really that the technology wasn't mature enough to decide on one, so they provided all 3. And well, I'm telling you a bit about history. I know that Klakke thinks these sort of talks are extremely boring. He doesn't like people telling him about punch cards either. But actually, this is the terrible truth. Well, I mean, this is what happens when you set up a committee to design a programming language. And of course, you can't really, I mean, the idea would be that to combine programs from different suppliers, but I mean, if you can't really build systems using different principles for systems design. So in 1999, I think that CCITT had dropped maintaining the CHIL standard. But anyhow, we picked up the idea. Pascal, well, that was the second language I was involved with. So we created this language, modules, process, but we only had process communications through signals. And we started with this from San Diego, Pascal, which was quite popular at the time, and then built on these other functions. Essentially, a process was like a Pascal main program, so you could start several of them. And they could communicate using signals, and there was a runtime system supporting that called REOS. And this was also used for some systems. Then another even bigger guy moved in, and that was the United States Department of Defense. And they wanted a language, and there was first a lot of work on creating requirement specification, and then there were 4 proposals which were color-coded, blue, green, red, or something, sent around for comments, and in the end it was a green that was chosen. Well, packages as another name for modules, tasks another name for processes. I mean, you have to be innovative. And task communication through Rendezvous. I met the ADA design team in Paris under the leadership of someone called Jean Ishbia. And this was Rendezvous in action. Here is one task, another task, and this would sort of call a procedure in this and get the results back. And at this point, it would also synchronize. So it was information transfer and synchronization combined. But that meant that suppose you just wanted to send a message from A to B, you would have to have some sort of mailbox in between. So first, this one does a rendezvous to load the information, and then the second does a rendezvous to pick up the information. But I mean, this gets a bit roundabout. So there were people called Habermas-Nassy optimization, where they, I think, sort of tried to hide this away. There were other strange things with Ada also, that in a package you could have tasks, and in tasks you could have new packages, and then you could have a procedure with tasks in. Ron Ishbia had the idea that you would call a procedure to perform some job, which could be done like several tasks in parallel, and then they would go together. I mean, this was a very strange idea. I don't know, I mean, some matrix application, you would have a task for each element or something. So, I mean, why did these people make process communication so complicated? And I think the explanation is simply that these were people trained in the old school of what programming was all about. It's like when you've been doing your courses in Pascal or something. A program is something that starts, reads input, computes, prints output, stops. And now they're supposed to talk to each other. So of course, the first thing is that springs to mind, that is Fortran common. They can have this data area, everyone could look in. So then there were creations of things called semaphores. You could say that, is it busy or not busy, etc. Well, but the thing is different if you start with parallelism. And that's natural in telephony. I mean, when you lift the receiver, your telephone sends a message to the switch that I've gone off. And that's done something and starts sending a tone back, etc. So, I mean, it's obvious you live in a world where there are different units talking to each other. So in 1980, there were 4 of us who went to the director of technology of the great big Ericsson organization and proposed to set up a computer science lab, because there were plastics labs, soldering labs, various other labs. Most design was programming. So yes, we should start a programming lab. And normally, these things are decided among the directors, and then they sort of find some sort of boss to organize it. But this was, we were coming from below instead. But I think Ericsson had lots of money then with the AXE10 systems. So yes, you could start this. Well, Mike, you know, Göran Båge is involved still in the Erlang world. Seven Torsten Dahl, he was the person that wrote the ERI-OS and made the ERI Pascal implementation. And then we were allowed to start. I mean, just imagine it. I mean, it's like going to the technical director of Ford Motor Company and say, "Oh, I would like to set up this thing on the electric cars or something." And yes, go ahead. So then we started, and we became sort of official in 1984. So then we had to write a job description, and the original document actually sits in Francesca's office. It's a present to him for all his work. and we must have had quite a lot of confidence. What are you going to do? Number one, create a new software technology for future telecom systems. We're not try to or something, but that's our job. And then help introduce new technology in existing systems. I mean, because, well, we're doing lots of things. It wasn't just that we had been working on these languages like PL163 or ERI Pascal or so, but we had got interested in Prolog and Lisp. And there was a project to create an interpreter for this Plex programming language with some 6 or 7 people involved. And then I did it in 2 months single-handedly in Lisp. I wasn't very popular in the other group. And the thing is just that it wasn't just that I was sort of clever. It was that this was like stealing candy from children. I mean, Lisp was so, I mean, the syntax analysis was an executable grammar. It got very declarative, very beautiful. So then, yes, we're on to something here. Perhaps we can move this sort of stuff into the real-time world or something. So we thought, if we combine all this stuff, we should be able to do something. And if we're going to have a laboratory to work on telecoms programming, we have to have a lab set up. And actually, we got a switch. This is a switch. ELU means extension line unit. TSU, tone sender unit. Tone receiver unit. Here was a switch, and here's the processor. So that if somebody lifted the receiver, they would be connected to tone sender, etc. At that time, the real-time system was like a one world. The programming development system was another world. I mean, we would perhaps be programming, sending stuff into the IBM data center, get the result back, walk over to this machine, load the program, and run it. So it was rather a heavy cycle. I mean, it doesn't look like that today. But then we had one very clever chap called Per Hedeland. He sort of rewrote that program. So you got all messages coming in here, going by an I/O unit, and then being picked up by this VAX station. So we had built a system where we could actually use the VAX as to control this switch. And of course, I mean, it wouldn't be fast enough for serious traffic, but I mean, this was just the perfect environment to do this sort of experimentation. And also, I should say, at that time, all program development were supposed to be sort of be done on the big IBM data center. They did not like these type of machines to be spread out in the organization. I mean, because it was a threat to their sort of power situation. But there's one reason that we were allowed, and you can never guess. It's because we were not running the VAX VMS ordinary operating system. We're using something extremely weird called Unix, which the data center were absolutely sure of would never ever spread. So then we did other things like on AI expert systems and so on, but that's another side. Then we started a series of experiments, and I think there were 6 or 7 people involved working sort of separately. We got hold of Ada, and we had a program. Concurrent Euclid was roughly like Chill. We had a parallel functional language, I think, from Gothenburg. The problem was just it was not dynamic processes. The processes were defined from the start. And we had some logic programming. Ops4, I wrote that, and various other languages. Strange things happened. For instance, in this logic programming thing, or in the rule-based system, the extensions had number 11, 12, 13, 14, 15. So I pressed the button 1, and it started ringing on extension 11. And then I realized, oh dear, rule for first digit and rule for second digit had both triggers. They thought it was 11. And another thing also was we discovered we can't really do backtracking, because if you are sent out a ringtone, you can't do backtracking and sort of take it back. I mean, and this, I think you should read this. I'll give you this. These are Mike's words, the results presented at the conference. So that's the outcome. We hadn't solved the problem. We had learned an awful lot, but we hadn't come to a conclusion. This is a way forward. That's still confused, but at a higher level, that's exactly. So what do we do then? Well, it's back to the drawing board. I mean, go to the pure basics. What's the problem we're trying to solve? And then apply all this other knowledge and try to move forward. And by that time, Joe had come, and Robert also. And we had a serious user group. There was a completely different prototyping team who were experimenting with architecture, and they wanted to build a system, but they wanted a suitable language or system to build their prototypes. And of course, a serious user group, that's like a walking requirement specification. And also, Mike, he knew everything about telecoms programming. I mean, both the applications and now about the language issues. Joe didn't know anything. He came from the Swedish Space Corporation, but Joe was a sort of pragmatic problem solver. He loved solving problems. So this was a very successful cooperation. And this is what it looked like at the workshop. We went to some skiing resort in 1991. And here you can see what they looked like at that time. I mean, it's obvious. I mean, here's Joe, the great enthusiast, waving his arms around. Robert is cool as ever. No worries, mate. I can't pronounce it in Australian. and then there's Mike. I mean, this was just a lab. I think 12 or 15 or something. But I mean, Mike has a white shirt, tie. I mean, you look proper when you are at work. It will be. But I have other pictures there, amongst them one of Robert in a heap of snow when he'd been skiing and sort of lost his balance. But the thing, you know, of course, what happened in the end. The important thing is that we did not want to invent a new language. That wasn't, I mean, the point was we wanted to solve this problem, but it wasn't part of the problem definition that it should be a language. But that is what happened anyway, because, well, we wanted to have a functional style, concurrency. There was nothing else. I think Robert can also tell what great big syntax wars when it sort of changed from a logic to a functional style. And I mean, its message reception comes from the telephony world, but I mean, the differentiation is done by pattern matching, which comes from logic programming world. I mean, this is a style, and it's also very important that has sort of spread. Suppose that Joe had been very possessive. So, this is my language, nobody's allowed to touch it. Erlang would have died. But instead, there's been people like Clucky coming along. I think we could do something about distribution. And it's gone on like that. I mean, but then we had this language. We have to put a name to it. I mean, well, Pascal, I mean, it's not Lisp, it's not Prolog. Is it Erlang? I mean, I said, how did Erlang get its name? I mean, you can't understand how it got its name unless you know about Pascal before. But then we said Erlang. Then, in telecommunications sort of computation theory, there is a unit called 1 Erlang. It's a measure of traffic intensity. If you Google Erlang, you find various companies who sell software to do this sort of work. And it's like if you study physics, you know that Pascal is a unit of pressure, sort of, I think, Newton over square inch or something like that. So that's where it came from, just to confuse you all. And it's a well-known term. You see, Erlang, oh yes. Everybody in the telecoms world know about it. It's okay, yes. And, well, you know, Pascal, Ada, Occam, also named after dead mathematicians. So, I mean, we could hook on to good tradition. So that. And by now, Ericsson has sort of chosen a new logo. they wanted to modernize. But then we felt, aha, well, as an old logo, free to use. So we thought, oh, yes, we'll use it. Ta-da! I think I spent 3 hours one Sunday evening taking it and then copying over. The A, the front is from the O, the back is from the N, etc. And this is an A with an extra squiddle, etc. And as you all know, that Erlang solutions have taken this slightly modified version of it. Some people thought this was a bit ridiculous, but I mean, look, Ford, Carlsberg, Coca-Cola, I mean, it's a good tradition. And so, but this is a really interesting aspect. All of this story can be reviewed by looking at the list of CS Lab publications. Here is a 1986, Experiments with Programming Languages and Techniques for Telecoms Applications. That was in Eindhoven, or as we say, Philipsburg. That's where we presented these results of this experimentation. And the text you saw before, that's a summary at the end of that paper. But then, as I said, we made a restart, and with Joe coming in with sort of a fresh look at this problem. Then we have these sort of papers. Phoning philosophers. Only Joe could have invented such a name. And then using Prolog for rapid prototyping. I mean, that's, you see, that's a different style of papers. Then this is where Erlang was presented to the world. International Switching Symposium. That was a great, big, huge, enormous telecommunications conference. I think they filled the whole of the sort of Globe Theatre in Stockholm. And it was sort of telecoms people from all over the world coming to Stockholm. And we presented a paper about Erlang. The interesting thing in big companies is most of our work had been sort of semi-confidential. But then when they want to show things, suddenly, yes, have you got anything to show? Oh, yes, we've got, oh, sure. But part of this conference was technical visits. The delegates were sort of sent by buses to Telia, to Ericsson, to other places, to visit laboratories and so on. And how many of you have seen the Erlang the movie? I don't know if you know the true background is simply that, yes, we got the chance to make a presentation that these foreign visitors would see. So during one day, there were, I think, eight occasions with people coming, and we made this presentation. We had the switch and everything. And of course, it's typical of Joe that, oh yes, now we made all this investment in building up this demo. Let's put it on video. So I mean, the video, this is a background. We didn't create the video itself. So, okay, now Erlang had been sort of exposed to the world. Now we get quite different kind of papers. Here, implementing a functional language for parallel applications. Use of Prolog for developing a new programming language. And prototyping cordless. The thing is that the International Switching Symposium, I think 2 years after, took place in Japan. Then Ericsson was not so conspicuous. Ericsson had only 4 papers, but 3 of them presented prototypes using Erlang. So, I mean, we're suddenly there. So you see, these are a different style of papers. It's a different situation. And now comes the real McCoy. This was Bogdan Hausman, an efficient implementation of a concurrent programming language. He came from the Swedish Institute of Computer Science, 6, and where he had been working on these types of issues. So now it wasn't an interpreter in Prolog which would sort of stop every now and again to do garbage collections. And now this was for real. And of course, what came then was, that was a book. And this was, again, Joe's idea. I mean, if you wonder about documentation about Pascal, well, it's difficult to find. They were essentially internal Ericsson documents. It took Joe to hit on the idea, let's write a book and get it printed by Prentice Hall. Well, I think that went a bit beyond what Mike and I had planned. I mean, we had the idea really of keeping a semi-secret, and Ericsson would have this as a commercial advantage, would be faster than anybody else in developing systems. Then for a while we got involved in some sort of complications at Ericsson, but it wasn't really our fault. I mean, it was a sort of competition between Ericsson Telecom, that's the old one, and Ericsson Radio. And we were associated with Ericsson Telecom. The Ericsson Radio people, they wanted to do their own stuff. And in fact, one of the reasons that Ericsson was so successful in mobile telephony was that the AXE10 system could be sort of modified to handle mobile telephony, which the Ericsson Radio people could never forgive them, because they had wanted to have their own switch. So of course somehow, oh yes, of course they wanted standard system, blah, 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 and all that, and nothing of this sort of weird language coming from Ericsson Telecom. Well, but this is past history. Management never agrees that they have made any wrong decision. It's just quietly forgotten. So that's the end. 3 wise guys, Joe, Robert, Mike at Belcore in December 1989. We were invited there to give an Erlang course, because there were some people at Belcore who were interested in new weird technologies. So, thank you very much.
Okay, do we have any questions?
Have you had the opportunity to play around with Lisp-flavored Erlang?
I haven't done it, but I mean, it's obvious that it would come. I mean, that's Robert's creation. Yeah. No, I'm a pensioner now. I'm a student of geoscience and archaeology, and I can give a long talk on the peopling of Europe after the Ice Age.
Anybody wants to hear about the Ice Age? Any other questions? No? Okay.
Look, can you not ask a question? Why is that thing at the upper corner?
Of course. Why is there this thing right in the corner?
Yes. Oh, thank you very much. That was a good question. Actually, you know that departments and units in big companies usually have some sort of letter combination, department, blah, blah, blah. So for several years, we had the department designation DU. And that meant that we had project called DU, the one Duper, and this was called Dundee, which in English is thunder. And so yes, we created this logotype. And if you look at CS Lab and there you will find this logotype again. But then I think we moved from one organization to another, and so this designation DU is changed to SU, and so my position, of course, SUC, C meaning sort of boss or so, but I would read it as stand-up comedian. So, thank you for a good question.
If you go to the previous slide, Bjarne, I thought it was only one of the inventors wore a tie, and I'm a bit concerned I see two ties.
Yes, well, these two guys were sort of brought up in, well, in good English, in not public schools, so I don't. And then you can guess who is who grew up in outback Australia. Crocodile Dundee. Okay.
Do you have any other questions? Right. Thank you very much, Bjarne.
Okay, thank you.